Now, this lecture on exponential growth is sort of like the last one, the first one. The situation is very similar. A type of bacteria splits in half, doubles, in other words, every, not 1 minute now, every 3 minutes, find the equation of growth. And that's what we're to do here. So we start with our petri dish. We got our one little critter there, and he's going to double every 3 minutes, split in half every 3 minutes. So we start out with one of them. But 3 minutes later, we got 2 of them. And then 6 minutes later, we got 4 of them. Okay, and then 9 minutes later, we got 2, 4, 6, 8 of them, right? We got 8 there. And so this looks very much like the 2 to the t. They're doubling. So we suspect that 2 to the t is in there somewhere. We also suspect the number 3 is in there. And usually when I ask students, they do things like, well, is it 3 times 2 to the t? Or is it 2 to the t over 3? And we try different things. And then finally someone says, of course we try them and we prove they're wrong. It's not hard to prove something wrong. You just have to find one example of it not working, and we throw the equation out. But somebody will finally say, what about 2? And they'll say, to the 3t. Well, that doesn't work. We try that, doesn't work. And then somebody says, what about 2 to the t over 3? And I'll say, let's see if that works. So I'm going to put 2 to the t over 3, and we're going to use the scientific method. We're going to put in 0. If I do that, I'm going to get 0 over 3, which is 0. 2 to the 0 power is 1. Well, it works with 0. I put 3 in, I'll get 3 over 3. That's 1. 2 to the 1 is 2. Well, that works for there. And I'll put in 6. And I'll put 6 here, divide by 3, and it's 2. 2 to the 2, 4. Well, it seems to be working. When you put in 9, it works. And then it becomes clear that this is really the equation right here. The number at time t equals 2 to the t over 3 if it doubles every 3 minutes. And then I say, well, what happens if it doubles every 4 minutes? And people say, oh, well, then it's 2 to the t over 4. I say, what happens if it doubles every 9.6 minutes? Then it's 2 to the t over 9.6. So however long it takes for this to double, you simply put t over that number. This is the number that tells you it doubles, and this is how long it takes it to double. Okay, if we go over here, we'll see the situation done again with a slight variation. Okay, so what we have here is a type of bacteria doubles every 1 minute, but we start with 3 of them. We're not starting with 1, we got 3. Of course, we could start with 30,000, but I decided to start with 3 because then we can see what's going on. So at time 0, I've got 3 of these guys. And then they're going to double, so I'm going to have 6, aren't I? And then they're going to double again. I'm going to have 12, then I'm going to have 24, and then I'm going to have 48, etc., right? And they're going to go just like that. Now we have to get an equation, n of t, that describes this. And again, I always ask the class, what could we do? And they try different things, and we see if they work. Because, if you put 3 in, then you got to get 24, right? It's got to come out right, this kind of thing. But then I point out to them, it's as though you're running 3 petri dishes at the same time with only 1. So it would be as if you had 3 experiments like this, 2, 3, like this, with a little nutrient in there with 1 each. And I said, if you start them running like that, what happens is somebody will say, well, you get 3 times as many. And they'll figure out, yes, that's right. So it is 3 times 2 to the t. And if we experiment with that, we get just what we want. If I put 0 in here, I'm going to get 2 to the 0, which is 1. 1 times 3 is 3, and I get 3. If I put 1 in here, I'll get 2 to the 1, I'll get 6. If I put, say, 4 in here, I'll get 2 to the 4th power, which is 16, and 3 16ths are 48. So it does work. So we prove. We're not really proving it. We're just showing, really, that it does work. Okay, we're using an empirical method here to show that it does work.